We're going to dive in and talk about how Dolby I/O enables your remote production workflows, and we're going to see a couple of different use cases from both Broadcast Management Group and Studiobox. So as an intro to who we will have speaking, myself, product marketing here at Dolby I/O. We also have Ryan Jespersen, who's a director of product here at Dolby I/O. Ian Smith, a co-founder at Studiobox, and Sean Wybourn, a VP of engineering with Broadcast Management Group. So no need to spend too much time talking about all of us because you'll get to hear from us later and at the Q&A. With that said, I'm going to turn it over to my colleague, Ryan, who can go ahead and kick off talking about Dolby I/O and how our real-time streaming product enables these remote production workflows.
Wonderful. Thanks, Tucker. And such a pleasure to have all of you here. I'll spend very little time on the slides. I always love getting into demos and showing technology in action, but I'll introduce Dolby I/O. What Dolby I/O is a high fidelity platform for media communications and streaming. And this can make your audio and video content sound its best, add interactivity with ultra low latency, broadcast quality streaming in the web browser, and allow you to build kind of immersive applications. This could be like multi-party video chat and embed that with this linear real-time streaming chat that we're going to show today to create these remote production workflows. So, what differentiates Dolby I/O? I think Dolby's a household name. People around the globe know that brand. And what Dolby I/O was built for is to kind of give you access through the cloud and through a developer platform to all this Dolby innovation, almost 60 years of Dolby innovation in immersive video and audio, and make that available through the web browser and through these cloud workflows. So we've built a lot of these tools to enable a plug and play seamless workflow. And I'm going to be showing that kind of plug and play approach with some of these workflows today. And one of the things that we focus on is obviously security, reliability, and scalability as we build these solutions into the cloud. Security is top of mind for people in the broadcast and post-production space. So let's talk a little bit about REMI production. I came from a startup called Millicast that was acquired by Dolby over a year ago, and we had built a production suite specific for remote post-production and live REMI production to enable live remote collaboration through the web browser. So what we tried to do, we had a simple approach. We're going to get broadcast quality video and audio and make it playable in the web browser in under a second around the globe. And we exceeded that expectation, and now we can get up to a couple hundred milliseconds round trip, glass to glass, anywhere in the world. So we have customers like the NFL, NBC built a product called NBC Rooms. During pandemic, they needed to enable this kind of remote collaboration. We work with CBS Studios. They enable live remote cameras from their studios in Hollywood so that people can see the live feed while they're doing a production of a commercial or a TV show or a movie. NASA has used us to do remote production for producing the Mars rover events and making that video content available to news agencies around the world. And then with Prime Video, we worked with them and NBC on the production of a AVP beach volleyball tournament that enabled a super small team to be able to go on premises to an AVP event during COVID and still produce an event. And Sean at Broadcast Management Group is going to talk about that exact workflow. And the NFL's used us to produce the Super Bowl the last 3 years. They have hundreds of cameras in producing the Super Bowl, and our technology allows them to get those real-time feeds. So what this does, it produces faster than industry standard satellite-based or fiber-based solutions. It's less expensive. It improves the reach because you can use a web browser to make that available to all customers and people working, the production team working on the project. And obviously, these are easier workflows for remote talent that maybe also needs to come on air. So this is one product that we've built, which is a REMI multi-viewer. This allows you to, and I'll show a demo of this in just a second. We can pull in multiple video feeds from a live event and make them available inside the web browser natively. So this is very different than trying to send SRT streams or NDI locally on a network. You can make this available through the cloud to a production team that's based anywhere in the world and allow the switching of this content through this multi-viewer. What this multi-viewer does is we've built one in the web browser where we can grab the streams directly from the venue. So this is some Dolby content that we have from a concert in Los Angeles. What I can do is inside the browser, I can show multi-view, and you can see now I can see individual feeds. So instead of having to produce one multi-view feed, and like Sean was mentioning, if you're the bug operator, the graphics guy, you want that to be your full, so you can see a preview of that from the equipment that's sitting at the REMI facility, 5,000 miles away. Here now I can switch in between these different ones and create whatever multi-view that I want for my experience. This could be true for REMI production, but it can also be true for the viewer experience, creating a viewer experience for a MotoGP race or a Formula One race, or allowing you to see Lewis Hamilton's camera inside of his helmet. This demo is actually available live. We have it running 24/7, and I'll put the URL in here so you guys can see the quality for yourselves. So the way you enable that multi-view is you click on the cog icon in the bottom right corner. You can show multi-view, and then you can switch the video sources either in the dialog here, and you can also switch the audio sources, which is important for a lot of live REMI use cases as well. And then we've also built this Dolby I/O stream monitor. This stream monitor is for Apple TV, iPhone, and iPad, and it's a free app that you can download and be able to pull up that real-time stream and share that in real time. So with that in mind, I'm going to actually jump out of the presentation and jump into a very quick demo. I think demo is always the best way to show technology in action. So when you go to Dolby I/O, you can sign up for a free trial. We have like a forever free account that you can use the Millicast service, which is the Dolby I/O real-time streaming service. As soon as you do that, you can log into the dashboard, and there's both a communication and media space, which is the video collaborative piece, the kind of communication video conferencing side, and then there's the streaming side, which is what we're going to focus on today. And when you first come in here, there'll be a token created. That's your first stream, but I've already created one here called OBS Studio. And here you'll see a lot of information about the token, the security settings. You can create additional streams within that publishing token. And then this is the important part for connecting your encoder or your stream workflow to the Dolby I/O service. You see we have a WIP endpoint, we have RTMP and SRT, and then we also have the ability to do playback. So what I've done is I've gone ahead and started this. We have a version of OBS Studio that we forked and added WebRTC to it. And we did this so that we could reduce the latency of RTMP and SRT to something that's in the hundreds of milliseconds instead of well over a second with some of those other workflows. So here I have some sample content. This could be a video project that I'm working on. I can even pull in my FaceTime camera, as you can see here. I can even do a picture-in-picture. And this is something I like to show so we can see both the video quality of the video content and then also the real-time nature of my FaceTime camera that's here. So what I'm going to do is under my settings, I've already connected that OBS or that Dolby I/O stream token. I'm just going to go ahead and start streaming. And when I do this, it's going to encode the content in WebRTC and send it to the web browser. Now, I've already copied this hosted player path, and what I'm going to do is actually post this in the chat window in the webinar so that all of you can take a look at this on your own device. And you'll see here, this is what it looks like inside of my web browser. I'm using Google Chrome, but this is compatible across Safari, Edge, mobile browsers, pretty much any device. And here between the webinar and the screen share, you can see the quality or the speed at which we're able to deliver this. Inside this player, we can pull up media statistics, we can see the latency, we can see the quality of the stream that's coming at us. And now this is something you can share with customers, you can share it with people who are working in a remote production staff. The other thing I was going to show is I have connected this to my Apple TV, and this is where it gets a little bit dangerous because I am pulling up QuickTime Player, and there's an ability in here to actually screen share my Apple TV. This is the one I have sitting in my living room, and hopefully it connects here. Sometimes it has a bit of issue. There it goes. So there is a screen share of my Apple TV, and there's my March Madness app. I'm not going to share that today, but here's my Dolby I/O stream monitor, and I mentioned this earlier on. And there's a little bit of a lag in the screen share between my Apple TV. But I'm going to go ahead and select that. And then in here, I've already got the details of this stream. So I can just hit the play button. And now you can see that real-time stream in Apple TV. So this is playing on my 4K TV in front of me right here, right now. And I'm doing a screen share of that. And once again, you can see the latency of this. So we can deliver not only to the web browser, but to these native SDKs and these native apps that can play on Apple TV, an iPad Pro that you can use as a on-set device, and so on. So 2 quick demos to kind of show you some of that workflow. And with that, I'm going to go ahead and stop this stream. And the demo, fingers crossed, it actually succeeded. Sometimes you have issues, as you guys know, with these live demos. So let me get back into the slides. And this is kind of what these REMI workflows look like. Sean's going to go through this workflow specifically for his company, Broadcast Management Group. But really what you're able to do is either get a destructive multi-view that comes out of your multi-viewer on set or in your REMI facility, and produce that, send that to Dolby I/O through SRT, RTMP, or even WebRTC through a protocol called WIP that we developed. And then we're able to deliver that in WebRTC to all of these devices that I've mentioned. So that's kind of the typical REMI workflow that a lot of customers are using us for. And then that same workflow is being used in remote post-production as well. So in remote post, we have people who are using Adobe Premiere Pro, they're using Avid, they're using DaVinci Resolve to do color grading and editing. People are even using us with Pro Tools to do audio editing on projects and music compositing for producing movies and TV shows and so on. So all the major studios have been using us. And this is a quote from Paul Downs, who was the executive producer of Hacks, an HBO Max original. And they mentioned that during the pandemic, they were able to use Millicast, which is the core of this Dolby I/O real-time streaming platform, which is this really fast and efficient platform that enabled them to do this remote production. And the workflow for that is very similar to what I just showed for the REMI production piece for live. We're able to grab the output of NDI from Adobe Premiere, capture that inside of OBS Studio, encode that in WebRTC, and send that through our platform for delivery in all the playback devices that I just demoed. And then Avid actually has a really cool use case. They actually just added SRT encoding into Avid Media Composer itself. So you can now connect SRT directly to our platform. And that enables us to not have to use OBS Studio. They have an encoder built into the product itself. So these are really, really popular products that are being used for both live REMI and remote post. And I know that was all really quick and it was a lot of information to digest. We will be sharing the slides. But the other thing I wanted to mention is we're investing a lot. Obviously, Dolby is extremely invested in the production and post-production space. And we're adding a lot of support into our platform to really mature the platform for this industry. So one of the things that we're working on is timecode support to be able to honor timecode, not only for remote post, but specifically for live REMI, so you can synchronize content and be able to see video inside of these live REMI workflows. This is too much information to go over today, but I wanted to include it in the slides. We'll be sending out a PDF along with the recording. And here it just shows you all the options that you have between capture, broadcast, the contribution into the cloud, which is our WebRTC CDN, this Millicast product, which is our real-time streaming product, and then the distribution side for playback. Apple TV, we're working on a version of that for Android TV, so you could build that on an NVIDIA Shield. And then we have all the abilities to build this into iOS, Android OS for mobile as well. So a ton of options for all kinds of real-time streaming workflows for REMI. With that, I love highlighting our customers, and we're going to pass this over to Ian Smith, the co-founder at Studiobox, who's going to give us a quick overview of his product and how they allow you to master remote production with their product. Go ahead, Ian.
Thanks, Ryan. That was awesome, by the way. That was a really cool demo. It's the first time I saw that. I will say working with the Dolby team is really, really cool because they're constantly working on new features and things I ask for, they'll say we're working on it or we're about to start working on it. So the time code thing was something that I really wanted to see happen. And there it is. So before I get into how Studiobox is working with Dolby, I'm going to just give you some a lowdown on what we're up to. We're a company that's focused on cinema quality in remote production. When when me and my partner started it about 2 months into COVID, we just noticed that cinema wasn't really in the remote video production world. It was kind of focused on broadcast, live events, and talking heads and that sort of thing. So we got to work on trying to figure out how to bring cinema level to remote production. And where we started was we needed to give people the tools and control over those tools in order to do that. So let me share my screen. I'll take you through some of my slides. So where we started with is we needed to build some hardware to get this job done. Let me click on this. Sure, there we go. So we built a portable studio in a box, hence the name Studiobox. It's everything you need to pull off a shoot, all in one unit that will just show up at someone's door. They open it up as easy as a laptop, plug it in, hit power, and they're off and running. And then someone can remote control every aspect of the shoot. So we've got a Blackmagic Cinema 4K camera in there. You're going to get 4K raw recording. You're going to get a 1080 proxy to a hard drive in the box, 2 channels of audio right to the synced right to the video. And Blackmagic has a good SDK camera control and a good developer community that you get to access. So by doing that, what we get control over remotely is lens controls like zoom and focus and iris, ISO, shutter, white balance, all kinds of display assists, a list of functions, camera functions that you get. And then we started figuring out how to control everything else. So we have a pan and tilt head on there to adjust framing. We're working on a version 2 of our box that should be done in about a month. And that's going to have elevate control. So you'll be able to change the height. And we've got a bicolored LED light built into the lid. And then we've got 4 channels of audio control, and you're going to control the gain levels, and you can also control how the volume comes out of the box, whether it's through the speaker or a headphone, or you can route those in different ways if you want a producer and an in-ear while the video feed's coming through the speaker or something like that. There's a 4K monitor, and we can put up teleprompter, we can put up the interviewer, program feed, anything we want there, a combination of things. And it does look like they're looking down the barrel of the lens when they're reading the prompter or talking to someone, an interviewer. So that's cool. It works exactly like a teleprompter. And the box is expandable, so we can add up to 6 additional cameras, 2 additional mics, so 4 mics total, and 2 additional pan and tilts, so 3 pan and tilts. So we'll often do shoots where we've got an A cam and a B cam, and one operator is controlling 3 cameras and 3 pan and tilts and audio and lighting and all of this stuff all happening at the same time from just one person remotely. So the primary benefit to trying to do cinema level shoots remotely is cost savings. You don't need a crew on set, and one person can kind of take the whole thing over and do it all remotely. So this has been the last 2 years. We've been working as a production company with this unique tech, and we've been servicing it. We've done over 500 shoots. Here we are shooting a Congress member. There's another guy. We got the 3 cameras. We had an extra light there. You can see the light in the lid. This was a 2 camera shoot, interview there, and then we've got one here. It's just a box with a teleprompter. So that's been out in the wild. And then about 6 months ago, we realized that if we were going to scale this business, we were going to need to put the control into the hands of anyone. So that's where we started leaning on Dolby I/O and started moving into building our own software, first to control these boxes, but then ultimately to control any piece of gear, anyone's gear, anything you might actually even own. So let me bring you over to our software, our work in progress. But this is, like I said, about 6 months in. We're a few months out from launching beta, but you'll see. You come in here and you can create a new shoot, and from here you can assign a box. So if you have a box assigned to your account, let's say you're renting one or you have one long term, we're hoping to put these in people's possessions for long periods of time. You'll choose the box and then set your date and location and give all the details of the shoot. Essentially, what this is doing is creating a Dolby token, a streaming token, so I can create different shoots, set up these tokens in advance, and have them all ready to go. So I've got one here. If I click on this, I get into the shoots folder. And if I had shot anything prior, I would see some clips here that are saved, but I haven't shot anything yet. I'm going to go into our control room, and there we will see, we got a couple team members, Max and Max, because we like to hire Maxes. There, so you would meet your crew, and I can assign, hey, Ali, I can assign people like maybe Max Ostrov is my cinematographer, Max Rutledge is my audio guy, and Ali's going to be handling teleprompter. And so one person can do all these jobs, or you can, break it up and assign people. So I might get notified that the box is online, meaning the person on the ground has opened it up, plugged it in, and hit power, and gotten it online at their house. I see it's online. I'll be able to hit start broadcast, and there we are. There's Serena. Serena's a producer for us. She's nice enough to sit in. So this is across town. We're all in here. I can see right away she needs some lighting. So I'm gonna go over to the lighting control. This is the light in the lid. I'll brighten her up. Obviously too bright. These guys are also in the camera controls, controlling things, so we can move shutter speed around, ISO. These guys are all in there moving things around too at the same time. And you can actually see who's moving what. Let me have a Max, one of you guys, move the shutter speed around. There we go. So it says Max Ostrov is moving the shutter. Looks like somebody's over here moving the frame. It's Ali. He's readjusting the framing. So we could all be working. It's a little hectic, obviously, doing this all at the same time. But the point is like you can see at the speed at which you can move, and how versatile it is, just even for one person to hop around. Even we can set up what do we have? Exposure assist. So if you want some false color, we have pro level tools for you to access. And yeah, and that's kind of what we're building here. So let me take you through. Thanks, guys. I appreciate you. Serena, you look great. Thank you. So let me take you back over to the PowerPoint and give you a little taste of the breakdown of how this works with Dolby. So I won't get too lost in the weeds here, but essentially right here in this zone, there are the three different APIs that we're accessing. We're accessing the real-time streaming API, which was giving us that image of Serena, crystal clear there on the monitor. And actually, there was a viewer link I was going to share with you guys, but it's all right. We'll pass by that for now. So there's a streaming app. There's the Dolby I/O transcoding, so we could hit record, and it's going to save a file and transcode it and save it in an S3 bucket in our own storage unit, and then a conferencing API for the crew there at the top. So we're actually using 3 of their APIs all at the same time, and there's information going both ways to the box here, which is, we've got sort of the back end and the front end, and then also to our operators, and the viewers are all getting information sent back and forth from these APIs. And then we're building our own SDKs around the hardware as well. So we're going to be able to make it super easy for anyone to also build on top of our platform. That's our sort of our future plans. But this is sort of a breakdown of how we're using it with Dolby, a rough idea. And then just to give you a quick, because my time's almost up here, these are a few images that end up coming from the box when you have someone behind the scenes working who knows how to use the tools. This is all just from one box. That one was a B cam. A quick case study with Masterclass. Masterclass hired us to do a test shoot. They wanted to see how close we could get to their actual shoots, and I'm very proud to say we got very, very close. So we pulled off one of their shoots for about a 1/30th the cost. On average, a Masterclass is about 50 crew members and $125,000 a day. They do it's like a full scale film shoot. We sent one PA on the ground, and one operator, and 2 boxes. So it was about $4,400 a day. And you can see the side by side. I'd say we got pretty damn close for that cost and 1 PA. This is the setup. They wanted to test 2 boxes because they wanted to try lighting on the second box, see if that could act as like a key or a fill. So we have 2 boxes. We sent 2 lights and a just very basic grip kit that we told the PA how to set up and do all that. So there was some extra lighting and whatnot to get the cinematic look that they were going for. But in the end, the executives at Masterclass could not tell the difference between their own shoot. They didn't know. They showed them the clip and they had no idea that was all done on a box by a remote operator. So
that's amazing, Ian. I mean, truly, I haven't seen that demo actually since TechCrunch last year, and it's come a long way. And it's amazing what we can do in the web browser now. It really is the future of collaborating and synchronous production.
And I will say, yeah, I mean, that's 6 months. Like the communication and the streaming thing was the first thing we did because it was in like weeks. We got that done in weeks, and then everything else has been stacked on top of that. So you guys just sped up the process immensely.
Awesome. Well, I was going to pass it over to Sean. So Ian's been focusing on their Studiobox product, and him and his team, which really helps with kind of that remote production, really reducing the cost of sending a team on site. A lot of it for scripted content like this masterclass. What Sean's going to talk about a little bit is REMI production or remote live production.
Well, awesome, Ryan. Well, thank you for everything, and thanks, Ian, for that great demo there. So one of the main things that I want to catch on is with Broadcast Management Group is news, sports, and entertainment. And the thing with REMI and remote production is basically REMI stands for Remote Integration Model. I just wanted to, a lot of people say REMI, and they don't actually really know what that means. I saw some comments earlier today, and we'll hit on it right now, on where to actually find Millicast OBS on the website. So as soon as you log in, you can actually go into resources, and you can actually see under resources on the right-hand side, will actually be the OBS download right here. So I'm not gonna actually download this right now for the demo, but I just wanted to show you how quick and you can find that here. And just note that there is the Intel and ARM version of the versions for OBS, and then also Microsoft there. So how do we use Millicast and Adobe I/O? Well, I'm going to show you right now. So today we use our multi-views via this process. So I'm just going to go ahead and create a token. And as Ryan said, he did a really good job on this earlier, so I don't want to spend too much time on this. But as I just created a token now, I can go into my publishing here. And with the Millicast OBS, I can easily just copy this token and name here. So I'm going to go ahead and copy this token. I'm going to go ahead and open OBS. And again, when you download OBS, it's not going to already have this input and audio set up for you. I've already preset this all up for you guys. So I'm just going to go into settings here and go into stream. And now I can easily just copy this token and name right into OBS. So again, this is going to be right under publishing token, and name. All I have to do is copy and paste. And I've already preset this all up, but these should all match up. I did mention you can go into more settings than that I'm going to talk about today. But right now, just to show you, our bit rate is 6.5 megabytes per second, and we are doing HS264. You can there's different options available, but we do that for compatibility of different devices. So I'm going to go ahead and start this stream here, and I can go back to Chrome, and under playback, as Ryan showed earlier, I can copy this viewer, and now I have this WebRTC WIP protocol multi-view from our facility in Vegas that is about 100 milliseconds, 200 milliseconds off of real time. And you may ask, what do we use this multi-view for? Well, I'm going to get into that next. So again, I'm Sean with Broadcast Management Group, and I'm going to talk about remote production and REMI and multi-camera productions, and why you would do it. So why would you do REMI productions, and what are the purposes of it? So what we found is we can bring the best customers, the best employees into our productions. Here's a great example. On Saturday nights, we have an NFL director that helps us with college games. Traditionally, in the traditional workforce, she could only do the NFL game because she's traveling on Saturday night and then traveling back Monday. Well, with our workloads, she's able to help us on that Saturday night and put a really good game out there. It also increases efficiency among your full-time staff. It reduces, like I said, travel costs. And then again, you're able to spin up and down questions. You're able to spin up and down productions as needed. What are some areas that you can do OTT and REMI productions? As I mentioned, OTT channels is one that's really over the last 6 to 10 years seems to be exploding. And how does REMI help with that? Well, instead of having to build 7 to 10 rooms to support a broadcast center, you basically can get away with just building a studio now. You have a studio for talent, and then basically everywhere else is either in the cloud or at our cloud control center. Where are other ideas? We've mentioned about sports. The one that I think right now a four-letter network where multi-camera REMI productions is hitting a lot is sports with football and basketball. But I will say where the next step is the smaller sports that don't get the attention, but much deserved attention. And the reason why that's going to come about is just that the cost to market because of REMI productions is so much lower because of the fact that we're able to be so much more efficient with our staffing. And then other areas is government, where we find government agencies wanting to help with REMI and stuff is, in the Capitol building and other areas, they might not have the infrastructure available to do a show or do a live production or show video content like they would want to. So you can utilize REMI and we can get the content to them where they need it. So what makes BMG unique with the way we do remote production? And on the left, I will say is our RMU1 unit, and on the right, I will say RMU2. And then for those broadcasters out there, I will say you'll be looking like this. Where's the 55-foot expando with 4 trucks on site? And that's the whole point of this. Our trucks and the way our remote production is we don't have our staff on site. We only have the people listed there, which mainly in the truck is our V1, EIC, and our camera ops. Everybody else is remote. So how do we get signals from our field to our cloud control center? Well, as I mentioned, a lot of these games that we do, whether it's entertainment or sports, it's a set, shoot, strike day. So we're showing up to these events for the first time 5 hours, 6 hours before the event. So we're testing that internet for the first time, normally, again, hours before the show. So at the end of the day, the goal of the production with REMI and everything else is the quality of the broadcast is as of most importance. So we tend to lean towards using a solution of live view products for our sports, and then for entertainment, we will use some TVU products. And if you're not familiar with the live view products, is that they're known for their bonding, and essentially bonding allows you to take in the LTE, 5G, 4G, and basically all your internet connections and bond the video signal back to home base. So essentially, if the venue doesn't have the internet connection available for us, we can then bond it, and LiveView will get the signal basically back to our cloud control center. Well, how do we handle audio? To make sure everything stays in sync, we will embed the video and audio at the truck, and then we will de-embed at our cloud control center. Now, what particularly makes BMG unique is our next step. Is not only do we have the field and our cloud control center, well, now we have the decentralized staffing part of this. So there's 2 big elements of that. We have the BMG with Adobe I/O low latency multi-view that I showed you earlier. That's via OBS and the WebRTC WIP protocol, which again, when we've demoed this and we've showed directors, which they're already always amazed by this, because I would say one of the things that's been so hard with the TV industry is everybody is very particular about, I need to be on site. I need to have the lowest latency possible. And then we show them what we're able to do, and they're just like, what? So the big test we always do is we have an iPad that has our WebRTC multi-view in front of them, and it's in front of a monitor in our cloud control center. And literally, they can look at the iPad and then look at the monitor, and they can't see a difference. So then we mastered the multi-view. So then what is our next step? Well, now we have to master comms. So we deploy KP32s and KP19s, and I'm not going to go too much details into what that is. But basically, in short, it's very similar to in production trucks. There are 16 to 32 knobs, and that allows full point-to-points or party lines with everybody. And again, so what this allows us to do is have our full-time staff, whether it's directors, producers, graphics, at home or at one of our spoke locations, directing a show with one of the Millicast multi-views with our comms panel. And ultimately, here's what that looks like. So on a typical show, we have our producers, directors, like I said, graphics person, all remote. And then the only people that are actually at our cloud control center is our TD and our engineers. A1 audio, we are able to do remote in a smoke location, but again, we're still exploring to make that remote. So just to give you a quick example of REMI and then also our BMG decentralized model, if you look in the blue here is a recent basketball game, and the orange is the hockey. if this actually happened last Friday, so just take a peek at the decentralized workforce that we did to put on this these two games for a 4-letter network. It's actually quite amazing, and it's for a lot of people in the industry. It's crazy how it's come about. So again, during these two shows, we had 20 inbound feeds, we had 24 outbound feeds, we did 14 multi-views via Adobe I/O. And when I say 14, every position has their unique multi-view. So a director is going to see one with cameras. A graphics person is going to see their fonts out. The replay op is going to see just the replays with programs. So we customize it to whatever they need. And as we go on, during that day, we covered 6 hours of live sports. So again, at the end of the day, I just wanted to recap and thank everybody. But I think the way the industry is coming and how fast with the technology and low latency multi-views and the comms and how we've approached, I think over the next 5 to 10 years, the way we do broadcast is only going to continue to change, and I think it's going to be fun to see and be a part of it.
Thanks, Sean. I think there's some incredible innovation going. If you can stop your screen share, Sean, I can reshare mine. Yeah, I'm really excited. I haven't been in digital video and streaming for 20 years almost now. I think there's a real the death of Flash is kind of pioneered in COVID as well, and the remote workflows. There's been this acceleration of a need to reduce costs. There's a green side to this as well, especially in Europe, where there are governments that are getting voted in. There are green governments that are in the majority in politics over there, and they have a mandate to reduce costs for a lot of national broadcasters. So these remote REMI facilities, the reduction in costs and personnel, and it's also really hard to find personnel. Sean's a colleague, Todd Mason, who's the CEO at Broadcast Management Group, referred this to me. There's an aging population inside the broadcast industry, and we need to enable workflows through the web browser to kind of, I think, make it more productive for people to do more content. Let's go ahead and take some questions. Tucker, I'll pass it over to you because I know you've been monitoring the Q&A chat.
Yeah, great. First off, thank you all for the demos and for presenting. This has been great. We do have a few questions, so we'll dive on in. I'll actually lead off with Michael's, one of the more recent ones we got, and this will be directed a bit towards Ryan. Can we, talk about the costs for a small operation for remote reviews for audio mixes? But what would that workflow look like, and if you were using Dolby I/O?
Yeah, it's a good question. So, we had one use case that we had is if you guys saw the movie Dune, it was that was produced during COVID, and a lot of the remote production, and I think they won an Oscar for the best original music or sound production, whatever that. Whenever Dune came out a couple of years ago, when they were in Pro Tools, the way that you have to review audio and sound effects, and obviously cleaning up audio from the live production set in a remote post environment. In Pro Tools, you can pull in a video feed that synchronizes with the audio track that you're working on. So what you can do with Pro Tools is connect that through NDI in our OBS studio, the video and the live audio. You can do an NDI audio out of Pro Tools virtually on the same machine into OBS, encode both the video and the audio that's coming off the produced master track. So what ends up happening is these audio editors and producers are scrubbing the timeline in Pro Tools. They're making changes in real time, and everyone who's in the web browser can be hearing and seeing these changes as they're working through collaboratively in this synchronous editing. So, there's a difference between that and kind of what Frame.io is, or some of these, that's a asynchronous NLE that you pretty much built in the browser. We're not that. We're the ability to enable synchronous workflows. And that's one example of how you do it in Pro Tools. We can probably dive a lot deeper into how that's done. And I think I've got a video I recorded on how to connect Pro Tools somewhere. But yeah, I think that's my high level answer. But that could be true as well for doing that for music. If you're working on music collaboratively and you're producing that in Pro Tools or other audio editing tools, you could connect that and be working collaboratively with other producers who are remote through that same workflow. From a cost perspective, obviously it reduces the cost of having to travel the same venue. from our cost perspective, it's actually really affordable. So the way we build this real-time streaming platform is based on bandwidth usage. And if you're doing an audio-only workflow, which we do honor and enable, it's extremely cheap because it's just bandwidth.
Awesome. Thanks, Ryan. Really quickly, I think we can end screen share so that we have full speaker tiles and everyone can see everybody a little more clearly. Thanks. I'm going to move on to a question that came in before the webinar for Ian at Studiobox. The Studiobox looks like a great product. Have you had customers use this for live events as well, like on-air interviews for CNN, etc.?
Yeah, we have. I remember one of the first ones we did was a 3-person panel for Bloomberg, where we delivered it to their control room and they handled the audio and video from there. And we've done some live hits to the Today Show, or Morning Show, some of the morning shows. Every single control room has a different requirement, which is something that we're thinking about all the time, and something we've talked to you about in requesting some SRT support, and here it is. You guys have built it. So yeah, we're always thinking about that, and we've done a lot of live events. And there's an encoder in the box itself, so you could do a live feed straight from the box if you wanted to.
Perfect. Thanks for that.
Mm-hmm.
We will move to a question for Sean at BMG. How do you process that many SRT streams from remote live view encoders for delivery to Dolby I/O?
Yes, that's a great question. So that's actually something that it's constantly evolving. And if you'd have asked me that, 2 months ago, the answer is kind of changing. So right now, whether with the demo I showed you today or majority of our streams is still WebRTC via the WIP protocol through OBS. So we are running VMware with a bunch of VMs that basically are running off either UTAP cards or Decklink cards, and we are able to stream out there. We've had some challenges among making more than 4 VMs per host, and that is kind of where we're looking at, because the expansion of the multi-view that Ryan said in one of his products is trying to get all our feeds up to Adobe, so that the viewer then or the operator can then customize their own multi-view and not in this destructive view. So we're going from that workflow now, from the the OBS workflow, to looking at how do we expand that further, whether that's through an NDI solution or whether that's through SRT. So SRT is something that is the industry standard that we've also been utilizing, and what we found with SRT is the quality is just about the same as OBS, and the delay might be just a tidbit more, but honestly, what we do have with SRT is we have racks of SRT encoders, and we've been testing different variable things, but I don't want to mention any names yet, because we've been I don't want to put my name behind some of the third parties we've been testing, because they're not fully vetted yet. So
yeah, I can add a little bit of detail to that. We're doing a lot of work on the vendor side with our strategic alliance partners at Dolby I/O to try to build these solutions. To add to Sean's answer, which was a great answer, is SRT is fantastic. Like it was needed to replace RTMP and pioneer the next generation of encoders and codecs and honor a lot of features. What SRT is bad at is that it's not built for web browser delivery, so that's where we come in. But how do you translate that SRT into us? You can't stream it directly into us, but what's happening in Sean's environment is obviously all going into his facility. They could restream SRT to us, but it adds probably more latency that they want with that protocol by default. So it makes more sense to do that in WebRTC. One way they're doing it now is that NDI and SMPTE 2110 were never really built. They aren't built for cloud delivery or anything outside of a local network. Even in a local network, NDI sometimes gives you issues. So we're trying to find ways to grab some hardware density server machines that could allow for the processing of that. And there's a lot of vendors working in that space. Hopefully there'll be a product that comes out. And so Sean and I are working very closely, and with several other customers, we're working to solve this exact same problem.
Awesome. Thank you both. I'm going to move back a little bit, a question that Daniel asked a little earlier, and this is directed, I guess, more towards Ryan. is what is the average video and audio bit rate that most are using with the Dolby Millicast product? They found that over 6 megabytes, sometimes the service struggles on the ingest side. So can you speak towards that?
There is like really no limit in the amount of bandwidth you send us. So I'd actually would like to see where you're having issues on the ingest. We've had customers do 4K 12 megabit per second streams, and it's honored that. The biggest problem that you have is the limitation of WebRTC itself. So you might be right. We just upped the limit from the playback side. WebRTC had a hard limit at 4 megabit per second. So right now we're in WebRTC, so we're all kind of sharing the WebRTC pipe between this product, Easy Webinar, and each of you who are viewing it. So all of our connections are almost like competing with each other, right? In doing that, we've just upped it in our platform to 12 megabits per second to allow for this multi-viewer that I just demoed, so we can send multi-viewer streams. As far as the recommended settings, like we get this all the time where someone wants to do 1080p. Well, if you do 1080p at 1 megabit per second, it's terrible. You're better doing 720p or even 540p at 1 megabit per second if that's your hard cap on your bit rate. So resolution, more pixels isn't a good thing if there's not enough data to back up the promise. When it comes to 1080p, at the very least, probably 4 megabits per second. I would recommend probably 6, like Sean's doing 6.5. I think he was doing with OBS. For 720p, I would say the very lowest 2.5 megabit per second. And we can get into the details of all the other bit rates. The one thing, as we talk about bit rates, is we do enable simulcast within our platform. And what that does is WebRTC has this by default where it can encode high, medium, and low. You encode your top one, and the 2 resolutions below are naturally selected for you. And our version of OBS enables that capability of simulcast because we have libWebRTC built into OBS Studio. And then similarly, we can also honor that workflow for SRT encoders or RTMP encoders. And the experience for the end viewer is better because you can obviously cycle through the 3 different renditions. For most live REMI use cases or remote post, simulcast is not a good idea because what you're trying to do is give the highest quality to your remote staff. But that simulcast feature is good for viewer playback if you're doing this for live events.
And for us, Ryan, we'll do between 6.5 megabytes upwards of 12. It depends on our home user. We love to push that up to 12, but we have found is if they don't have that good hardline internet connection with low latency, then we have to push back down to where you saw we were at 6. And that's probably where you were seeing some of the issues. It's probably the local internet and not where the encoder actually is. It's probably where you're viewing it. Are you using Wi-Fi? Because definitely when you're pushing that, the low latency viewer and the internet is with latency is everything.
Yeah, what happens? WebRTC works over UDP by default. What UDP is built to do is built to prioritize latency over resiliency. So what it means is if you have a poor connection, like I don't know if you guys got Sean's camera just now kind of went out for a bit because his connection, there might be some issues there. We still got him in real time because it's dropping those packets, but the priority is getting his video signal to us despite maybe poor connectivity issues. So that's how it works by default.
Great. Sean, we have another question directed at you. Could you quickly talk about if you're able to get full CCU remotely as well over SDI? The curiosity is around how all remote feeds stay in sync coming in.
It's a great question. Let's tackle that latter question first. So the advantages of us using LiveView or TVU is they actually sync everything at the encoder side. So with our LU800, they're 1RU boxes that take 4 cameras at a piece. And when you are encoding that, they're injecting that time code when you're encoding. So then when they get to the decoder, there's actually a set amount of delay that you set. So if the video signals arrive at different times, the decoder is going to look at that time code and make sure that it comes out of that unit at the same exact time. So that is how they stay in sync. Over the past couple of years, it's amazing how that technology has come. Where when it first came out 3 years ago, they did drift, and we had to work around that. But now it's a frame. It's the same. If you were playing one video and you send them all down our feeds, and we done testing where we left them on for 4 days, it was still 4 days later showing frame to frame locked video and audio. So, the technology is pretty amazing. When it relates to remote CCU, it's funny because I was on an event last week for a basketball tournament, and we were actually talking about that idea of remote CCU and that remote workflow. So today, our video shader is actually still in the truck, and a part of that, and we believe to this day, and we're going to kind of keep this method, is that the video shader, the V1, is kind of still like a video engineer and kind of works with the camera ops. So that, going out there, helping the camera ops where they need it, helping them with back focus, helping them with focus is still so important. So to this day, we're still probably going to leave our V1 shader locally on site because of that reason. Now, is the technology there for us to have a remote shader? If we start to do 24 camera games, we might explore that idea and having the latter part of the cameras, shaded from our cloud control center. But again, the dilemma there is just, the having to physically help the camera up with something is not possible. And then also, lastly, just the physicalness of if we have to turn on the CCU or not. So that just puts more on our engineers. So I hope that answers the question.
Yeah, and let me add a little bit of detail to Sean's first answer about synchronization. So we've never really focused on that from a product perspective because we deliver as fast as we can deliver. So because we can do things within a couple of 100 milliseconds, glass to glass, there's never been a need to try to sync that content in any way. The timecode slide that I shared is trying to solve that. But for us to sync it, we actually need to add a buffer, which means the latency will go up because some streams are going to be slightly faster or slightly slower than others. So, I don't know, adding buffer to our solution, which is trying to reduce the latency, it kind of goes against our very nature. But we do understand that live REMI needs synchronization. But if you try our platform out and see it, you'll see that sync, at least for making decisions in remote production staff environments, it doesn't need the sync, right? Because you're not using it for the actual production program feed out. You're just using it as a monitor, confidence monitor.
Awesome. Thank you both for that. We probably have time for one, maybe two more questions. Ryan, this one will go to you again, more focused on Dolby I/O. It's from Jeff. Are hub-based hybrid conferences considered a valid use case for Dolby I/O? Example, a conference held in 3 locations in which the participants interact with each other using video streams through Dolby I/O, and the proceedings are streamed. So I believe we have something very on point to talk about here with this answer.
Yes, if I understand it correctly, and there was kind of a related question, and by the way, I know we have 3 minutes left. I'm okay going over so we can get through questions if everyone else is, because I know there's a few here for Ian as well. As it relates to, there's a question about Video Ninja. There's this product, it used to be called OBS Ninja, but they've changed it to Video.Ninja. It's a really cool product. It allows you to pull in a web browser, WebRTC video, which could be a remote guest, and have it as a source in OBS Studio. So that way you could actually produce kind of like more tier 3 live events. You could use OBS to do that. Obviously for what Sean's doing and that kind of stuff, they're doing things in a broadcast REMI capacity. But think of like Ian's product. If you're actually trying to pull in, you have this nice Studiobox you've sent out, you want to pull that feed into a live production. How do you do that? There's a lot of evolution happening in the space here, and it gets quite technical. I'll pull up this slide just to show you, kind of talk through this. But I think you guys have probably seen, those who have been in production have seen a CNN interview where there's a Skype logo in the top right corner. And that's using a product called Skype TX, which is this $20,000-$30,000 product that Microsoft made that kind of sits on top of Skype and tries to make Skype enabled for broadcast workflows. That product, as Sean can probably attest to, is garbage. Like the quality you're getting is video conferencing. You don't control the broadcast quality from point to point. It goes into the black box that is a broadcasting service. I think Zoom kind of suffers from this as well, is they're built for video conferencing. They're not built for broadcast quality. So one of the things that we're working on with our partners at Osprey is the ability, let's say you can send a web browser link to a remote guest, or you're using a Studiobox, you're grabbing that video feed. How do you get that into a studio to mix it? Right? Whether it be OBS or a more brick and mortar studio like Sean's REMI facility, you want to pull it into an SDI vision mixer. So one of the things that we're working on with Osprey is the hardware's coming along, and their encoder decoders used to be different boxes. Now they're the same hardware. And within that same hardware, you can buy it, use it both for encode and contribution with WIP and WebRTC. You can also use it for WebRTC playback and decode to SDI into a studio that you can now mix that from a WebRTC source, either in browser or from a product like Studiobox. So that kind of throws everything on its head in the broadcast industry, because now you're not going to buy a Skype TX product or some expensive remote gear. You can be using WebRTC to deliver that into a broadcast facility for mixing, which is a really interesting concept. And by the way, you can do that for pennies on the dollar as it compares to what broadcast has been doing for a long time. So there's another question about Video Ninja, and I'll have to follow up with that person directly, because there's some things you can do there as well. But that's a really exciting thing I'm seeing on the, and the way we're doing that, by the way, for playback is through WIP is the standard contribution protocol to try to make WebRTC ubiquitous for streaming from an encoder or a client. WEP is doing the opposite. It's trying to standardize the playback. We're doing this, we're pushing WIP and WEP to try to standardize using WebRTC across the broadcast industry, make it easy for people to build, like Osprey is doing with their products.
Awesome. Thanks, Ryan.
Yep.
Let's see. We can go to one more question for Ryan again. Using the web browser as a decoder and playback device is cool, and we just talked about WIP and WEP. You know, where do you see the future for the encoder decoder market going?
My answer there is quite controversial. You know, the fact that a web browser can already do, like our CTO at Millicast, Sergio, was able to enable, enabled a year and a half ago now, almost 2 years ago, real-time AV1 encoding in the web browser that could actually honor scalable video coding, SVC. He did that in a web browser, in a canary version of Chrome, way before any hardware encoder was able to do that in the market. What you can do in software now, and this is true of cloud resources, everything's leaning towards CPU and away from GPU for the most part. And when you think about what an encoder is, it's just kind of an edge device that has a GPU in it and CPU as well. But I truly believe that within 10 years, the hardware encoder decoder will be gone. And all these encoder companies have to find cloud-based workflows where they can add their value, or add value at the edge, like a lot of companies are trying to do. Companies like Videon are working a lot on those kind of things. But obviously, I'm coming at this from the web model, not from the broadcast model. Sean probably would disagree with me on a lot of this, because you know, the rack-mounted encoders he uses every day and the live view boxes are pretty amazing. A lot of the stuff that they do, and for that to all be in software we're probably a ways out. What's your idea on that, Sean?
Well, I think from if you think of the typical DUSE environment, how are we going to get the standard camera to a web browser that's, you know, covering the news? So I think in that scenario, the encoders are still going to exist. Maybe it is you know, some more software obviously involved, but you know, I think now at the, you know, where things are actually happening, where, you know, I do see that things are moving more towards the cloud, and I think the move towards cloud production is only going to, you know, force that even further.
Thanks, everyone.
Thank you, guys. Thank you.
Everybody have a great rest of your week, and we will follow through with a recording soon.
Bye, guys.
Awesome. Bye, y'all.